All right, today we are looking at Unit 12. We are starting on solving quadratic equations. To build ourselves up to that, we've been learning how to factor. We've been learning how to factor trinomials, how to factor out greatest common factor using those things. Today we really take that a step further. We're going to start solving quadratic equations, and realistically there are multiple ways that we can solve a quadratic. But I wanted us to start with factoring because that's what we just got out of. One of the ways that we can solve a quadratic equation is if that polynomial is factorable, we can factor, okay? And once we have factored, we set our factors equal to 0, solve for x, and we're done, just like that. And I kind of have those steps written out right here. For us, if I'm trying to put it to where I can factor it, it needs to be in this form. It needs to be in that standard form of ax squared plus bx plus c. Because just like when we were factoring, we need to be able to identify our a, b, and c and factor from there. And so once we have it in this form, we're going to factor it. Like I said before, we can set each factor equal to 0. This is the zero product property that tells us if two things multiplied equal 0, then one of them has to be 0. So if you set it equal to 0, you can solve for x, and that's exactly what we're going to do. So to just jump right in, I have some examples here, and I'm just going to take a look. We're just going to start right here. Clearly, this is not in the form ax squared plus bx plus c. Like we have our equation split into two separate expressions. So I am going to move this negative 3x minus 2 back over. That way we can set it equal to 0. To do that, I'm just going to use inverse operations. I need to move the negative 3x, so I need to add 3x to both sides. And then, of course, what I add to this side, I have to add to the other side. And I have an x value to add that to, right? So I'm going to go ahead and add that right now, and we're going to get x squared. Negative 6x plus 3x gives me negative 3x. And then I would put equals here, but we still need to take care of this negative 2. So I'm going to go ahead and add it to both sides too. And since we don't have a constant to combine it with here, it's just added on equals, and nothing's left on this side, so 0. Now, I have that. I have something I can factor. I can set up my ABC. We can create our x. Remember our little x game that we play. And on top, we have a times c, which in this case, that's 2. And on bottom, we have our b value, which is negative 3. Factors of 2 that add up to negative 3. Well, first off, for the top to be positive, and we're finding factors of it that are going to add to a negative number, that means that both of our factors need to be negative numbers. So we have negative 1 and a negative 2. Negative 1 times negative 2 gives me positive 2. Negative 1 plus negative 2 gives me negative 3. So those are my factors. We would group. So if I group those together, I would just have x squared minus x. That's that 1, because remember we don't have to write a 1. And then we would have negative 2x plus 2. And when I factor out our greatest common factors here, what we're going to end up with is we have x that we can take out here, leaving us with x minus 1 on the inside. And on this side, we should end up with x minus 1 on the inside as well. If you have a coefficient or something with the x that is negative, you can take that negative out. So that's what we're going to do. We're going to take out negative 2 because we can take out a 2 from both, and we want that negative gone. So I'm going to take out a negative 2, and we're going to divide both sides by that. When I do that, we're left with x still, and 2 divided by negative 2 is just negative 1. And that's kind of confirmation that we did this correctly because both of our inside factors look the same. And from there we have x minus 2, that's my outside factors, and x minus 1, that's that inside factor. Okay, this is where we would have stopped, but we are not factoring now. We are just using factoring as a step off to solving this quadratic. My last step here is to just set both of them equal to 0. So I'm going to say x minus 2 equals 0 and x minus 1 equals 0. And then I solve for x. So in this case, I'm going to add 2 to both sides, giving me x equals 2. And on this problem here, I'd add 1 to both sides, giving me x equals 1. And those are my two solutions. We can sometimes end up with a single solution. We can end up with two solutions. Ultimately, for the most part, you'll always end up with two solutions. X equals 2 and x equals 1 is our solution here. We're going to go ahead and try another one. Let's see, I have x squared plus 7x minus 24 equals negative 6. I'm going to go ahead and add that 6 to both sides. And when I do that, we end up with then adding 6 to both sides, making sure the constants go to constants, like terms. Making sure that now we have x squared plus 7x minus 18. Okay. When I factor this, if I set up my x, on top of my x, 1 times negative 18 is just negative 18. And on bottom we have 7. So two numbers that multiply together to make a negative 18. So that means one of our numbers will be negative, but add together to make a 7, a positive number. So not only will one of our numbers be negative, but more importantly, our larger number will be positive. So if I look at factors of 18, we have 1 and 18. That would just create negative or 17. We have 2 and 9. Negative 2 plus 9 is 7. So there we have it. Negative 2 and 9 are my factors. I'm going to break those up into their groups. We're going to say x squared plus 2x. Or I'm sorry, not plus 2x. Let me just rewind a little bit. Minus 2x. Getting a little ahead of myself here. Then, in my other set of parentheses, in my other group, I'm going to have a positive 9x minus 18. And we're going to factor out the greatest common factors. Here, the only thing we can factor out is an x. So I have x, and then inside I still have x minus 2. And then here, I can factor out a 9. And as confirmation, what I'm left with when I divide is x minus 2. So my two factors here are x plus 9 and x minus 2. Set those both equal to 0. X plus 9 equals 0. If I want to get x by itself, I'd have to subtract from both sides, leaving me with x equals negative 9. And then I have x minus 2 equals 0. And then when I subtract, I'm left with, or I'm sorry, in this case I'm adding, it's negative 2, so I'm going to add 2 to both sides. I'm left with x equals positive 2. Okay, and those are my solutions, negative 9 and 2. I'm going to look at one more with you guys. I think I'm going to look right here at x squared minus 49 equals 0. You'll notice this isn't in the form ax squared plus bx equals c. Or rather, it is, but b is 0. I don't have an x value here, so b is 0. My a is 1, my c is negative 49, and my b is 0. So if I were to actually set this up to factor it, and technically this is a difference of squares, but if I set it up the same way we set up everything, I would do negative 49 up top, that's a times c, and on bottom I'd have 0. But the zero property product, well, this wouldn't even use the zero property product, right? We're not multiplying to equal 0, we're adding to equal 0, which means our two numbers need to be the same. So what number multiplied by itself equals 49? And my answer here would be a 7 and a 7, but one of them needs to be negative. because we need it to equal a negative 49, and when we add them together, one needs to be zeros. We call that a difference of squares. When the square root of your value, not the sign itself, just the value, provides you with your two factors that go together, and one is positive and one is negative. And if I were to break these up into groups, there wouldn't really be a group to break these into because I have a zero. These are my two factors that I'm working with. I'm going to have x plus 7 and x minus 7. Okay. And even if we applied that as the substitution, so if I rewound and we pretended that there was a b of x for us to replace, we would just start with x squared. I'm replacing it with 7 plus 7 and x. And then on the other side, negative 7x minus 49. I'm going to factor out the x. That's going to leave me with x on the outside, and on the inside, x plus 7. And over here, I'm going to factor out the negative 7 because they're both negative, and I don't want a negative x value. So I'm going to factor out the negative 7, and what that's going to leave me with is x plus 7. So my factors are x minus 7, those are my outsides, and my inside, x plus 7. Okay. Once I have those, all I have to do is set them equal to 0. If you haven't recognized this pattern now, it's just the opposite value, right? We have negative 7 equals 0. We have to add 7, so x equals 7. So whatever the opposite of that factor is, the inverse rather, if it's positive, it's now negative. It's negative, it's now positive. Here we have x plus 7 equals 0. And when I subtract 7 from both sides, we get x equals negative 7. Okay. So sometimes we'll have where b is 0. There is no b value. And that's perfectly fine. We could even have where c equals 0 and we treat it like a 0. And we can still set up the problem. We can still find factors. But it's a big tip if you don't have a b, if your bottom is 0, that these two factors are going to come from the square root of your a times c. So the square root of 49 is 7. And we're going to have a positive and a negative 7 because that's what makes it a negative 49. Okay. I hope this was helpful. I want you to try to practice doing the 3 that we have remaining here. And we're going to work on this. We're going to have some deltas related to this. They look kind of like this. They set it up and they want you to factor it. There are a few problems like this. You'll have some where you have to obviously set it ax squared plus bx equals c. You'll even have some, in this situation, if you just look, 2x, I'm going to have to subtract from both sides, and that's going to cancel out this x. Our b is going to disappear. So we'd have x squared minus 9 equals 0, which is exactly kind of like this example we did here, where we didn't have a b value at all. So keep that in mind. Obviously, if you need help with anything, please don't hesitate to ask me, or we can go over it together. We're going to spend the next couple days working on solving quadratic equations with factoring. And then next week, we're going to take a look at how to solve quadratic equations when it can't be factored. We're going to look at what to do when it can't be factored. I hope you have a great day. Bye.